the data, we translate it or we configure it, we have to configure the Civil 3D environment, tell it that we're working in this coordinate system, for instance, this system, metric versus imperial, etc. And from the data that we get, we ask Civil 3D to create a surface from the GIS data or the other data that we've got. So this is being run. And by the way, the user who's using Civil 3D, he's an expert at Autodesk. He's the expert of Civil 3D. And then he's going into these steps at a time. So you can see there. Now we're capturing imagery. So we're getting the satellite imagery from the built-in sources inside of Civil 3D. And then finally, importing vector data if we need to. So the final result is what you see there. Now we move into InfraWorks, and this is what we call the model builder. It's a free feature from Autodesk, which is very quickly, you can go to InfraWorks, tell it, I want to create a 3D model for the city of Istanbul, for example. Within seconds, it will open. I will show it. Okay. Let me go back a second. So this is InfraWorks. And inside of InfraWorks, we're going into the model builder. Very easily, we type in any city in the world, and it will create the 3D model for us. The cool thing about it, it does not require extensive knowledge about the coordinate systems and the data sources that you're pulling in. Just you have to open the model builder, zoom to the area of interest, and just ask the software to create it for you. This is utilizing the power of the cloud, and it's pulling data sources from partners of Autodesk to create the 3D model that you will see in a second. So some of the data sources are OpenStreetMap, Bing Maps, SRTM, and many others. So here I'm just putting, we're putting the city of Cape Town, the capital of South Africa. We're highlighting, as you will see in a second, the area of interest. And for now, you can actually select an area of up to 200 square kilometers, such a big area. So we're selecting that. We're naming the model. You can name it whatever you like. Istanbul 1, Istanbul 2, etc. You hit close. You can actually share it with a certain group of people. And within 5 to 10 minutes, you will get a notification by email saying your model is ready. It will show up as a thumbnail in your InfraWorks homepage. You click on that thumbnail. The model downloads within 5 to 10 minutes as well. And you will be able to see in a second what you will get free of charge. You pay nothing for that from Autodesk. So this is the model that was created in Model Builder inside of InfraWorks. As you can see, we have the terrain. We have the satellite imagery superimposed. We have also the buildings. We have like the plots and the heights of the buildings and any water bodies. So if we have a sea, we have a coastline, we have lakes, everything is in there. Now some people say, what is the accuracy of this data? It's as accurate as the data sources we're getting those from. And it's dependent from one region to another. So in the States or Europe, it's very, very accurate. In our region, it's less accurate for too many different reasons, because usually municipalities or governments are not willing to share the data or put it online. But it's pretty much accurate for conceptual design. So this is one thing, a benefit of using InfraWorks. Now definitely, Civil 3D steps in for creating accurate ground data that we sometimes need for the detailed design. So if you want to create a detailed design of a certain existing terrain and then sketch your low roads and do the cut and fill, then Civil 3D comes into the picture. And definitely, Civil 3D helps us with the contours and contour labels, as you already know, the symbols of the objects there, plus many other things as well. So this is the first point that I wanted to touch. And definitely here we're just highlighting kind of the differences. There you have to be an expert in the data and the tool itself to create the existing conditions, whereas with InfraWorks, it's basically like few clicks, and it's a very user-friendly interface, as you can see, compared to Civil 3D. Saves a lot of time and gets you a very visually compelling model. Second of all, I'll move into the preliminary road design. So inside of Civil 3D, to create a preliminary road, right, to get its cut and fill, the profile, the sections, etc., it takes us a lot of time, right? Let's see how we can do that inside of InfraWorks. So again, we have here the video, and we have the same thing as well, the steps. So what you're seeing in that video is the steps we're going through to create a single road at the conceptual stage or preliminary stage. We usually sketch the path of the road, the center line. We create the alignment. From the alignment, we create the profile. Then we design the profile, design the secondary road if we have a certain T intersection, for instance, create an assembly or use one of the assemblies available and apply it to the road. Those of you who already use Civil 3D know what I'm talking about. But because it's running quickly, we cannot go into the details. So it's going through those steps one by one, creating the corridor in terms of a 3D, and from the corridor, create the corridor surface, design the intersection, which is also sometimes tedious, and finally do some final touches on cleaning the design. So this is the process each and every engineer goes through to create a preliminary road inside of Civil 3D with a T intersection. Let's compare that to InfraWorks 360, the new tool from Autodesk. The same thing, you can compare almost 9 to 10 steps inside of Civil 3D to just 3 inside of InfraWorks. It's too fast that if I click on the video, you won't be able to see it. I'll just move directly to the video. And let me just show you what I'm doing here. We just picked a road style. So inside of InfraWorks, the road styles are already built in. And the cool thing about InfraWorks, you can create the road styles of your country or your city. So if you have standard road styles of Istanbul, you can create a library and use them into all of your projects. We just selected a road style, and not just a road style in terms of the visuals, where do we have the light poles, what is the width of the pedestrian path, etc. We can also specify the design speed. And that design speed will limit the horizontal and vertical curvature of the road. So it's not like sketching things, it's basically designing things in 3D. And what we're doing there, once we selected the road style and the, for example, here, local road, which is limited to 45 kilometers per hour, once we're sketching the road, it's giving us direct feedback if this is allowable as per the standard or not. So even if you're not a civil engineer and you're violating the standard, it will actually give you a black curve instead of a blue curve. So blue curve, you're not violating the standard, you continue on, and it's giving you direct feedback about the length, the station, the cross-section, etc. So if I run the video, I'm just selecting points. So I want to connect that point to this point, and on the fly, connect that point to that point. It created the road, it applied the style, it did it in 3D, and created the intersection by its own. So what took, let me skip this, what took almost 20 minutes to be done in Civil 3D took us less than a minute to do in InfraWorks 360. Now the question is, why don't we use InfraWorks all the time? InfraWorks is very powerful if you're sketching things. But what if you want to generate, for example, the cross-sections or the alignment, profiles, and the documentation? Then the only way to go is definitely Civil 3D. So InfraWorks is very good at sketching things as per design, showing them visually to your customers. But for documentation, the plan and profile, annotation, the section sheets, adding details and notes, it's definitely Civil 3D that is really required. So this is the second point that I wanted to touch upon. The third one is storm design. And here we do have certain challenges. The ones of you who design storm drainage networks for any road, like we're seeing there using Civil 3D, know it's a pretty tedious job because the designer himself has to place each and every structure, like an inlet or a manhole, and align them with the road with a certain slope. So you can see there the manual process of creating each and every structure and placing it where it should be. So the designer is going into finding the low points first. So he has to analyze where are the low points in our design. So we have a dip. We have to analyze those, lay out the spacing where I want to place these structures, create the inlets and pipes, reposition them, change the pipe sizes to accommodate for the flow of the storm that's coming onto the road, create more pipes on inlets if required, and finally calculate the quantities. This process takes, I guess, more than 20 minutes, and this is with an expert in Civil 3D. So if I roll it further, So it's getting faster and faster until we get to InfraWorks 360. We won't have the time actually to tell you what is going on because it's that quick. So what is really being done in InfraWorks is just 3 steps. And this is also making use of the power of the cloud. Let me pull into the original video. So what I'm doing here, we have a road that we have sketched as per the standard, or we brought in from Civil 3D. All what I have to do is make use of the, let me show you by the mouse, the drainage module. So here, for those of you who don't know about InfraWorks, we have the basic features, we have the road and design features and capabilities, we have the drainage, sorry, we have the bridge, and this green one is the drainage. So here we can design for any storm drainage network on roads. So I'm opening this drainage network and I'm asking the software to add automatically a pavement drainage command. So just select the road in 3D, right click, and push on the add pavement drainage option. So basically 3 clicks. Once I click that, the software will allow me, let me go back a second, will give me another window where I can specify the type of, for example, manholes, as you can see here, the circular and the inlets. There are built-in libraries for those structures, which you can also create for Turkey and utilize in your project. They will actually be in 3D. Once you select those from the library, you hit OK, and within a couple of seconds to 10 seconds max, the software will generate the pavement drainage, storm drainage network throughout all of that road in 3D. Not only that, it will also give you the quantities. So it will tell you need this number of manholes, this number of inlets. These are the pipe diameters, and this is the length for each diameter type. So all of that is being done for you on the fly. Not only that, we can actually size the pavement drainage. So the software will automatically lay those structures for you instead of doing them manually in Civil 3D, but also will size them for you depending on the rainfall data. So if you have the rainfall data for Istanbul, you know how many cubic feet per second, blah, 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 you can input that into the software and it will do it automatically for you. Once it's done, so it will update the manholes, it will update the pipes, and it will also update the quantities of the pipeline. So as you can see there, it's in 3D. Okay. So the result is a system with sized pipes and outfalls. We're not just laying them in 3D, but we're resizing them depending on the rainfall data that we've got. So the whole of this process took us like a minute versus over 20 minutes in Civil 3D. Now definitely, we're done with the conceptual design, we're happy, we know where the structures are located, what is the size of the pipes, etc. We move that data into Civil 3D, and that is where we can leverage the storm and sanitary analysis module. How many of you already know the storm and sanitary analysis module in Civil 3D? Just 1, 2 maybe, okay. This is a very specific and very professional module that you can create inside of it all of those structures that you use for drainage design and do all of the simulations of the flow inside of the pipes and the structures to analyze if there is any pipe that needs replacement, bigger size, etc., etc. So Civil 3D is still the tool required for detailed design. But for preliminary design, for laying out the network, resizing it, InfraWorks does the job very quickly. So again, this is just a summary of the results. 3-step process versus a very tedious and time-consuming process. It requires less expertise, and it's very visually compelling because you can see everything in 3D, and you can actually analyze if you have any existing utilities underneath your road in InfraWorks. You can see if, for example, certain utility or certain electricity line is hitting any of your structures. You can move it back and forth easily. So there are many benefits for using InfraWorks besides saving on time. The fourth thing is basically stream crossing and analysis. And this is where we move kind of into hydrology, not hydraulics. So for the city of Istanbul, you have too many mountains, right? You have a sea. So it's very important to analyze what we call the watersheds, the areas that will gather the rainfall and will collect them into certain streams like rivers. And this is where we can leverage also the power of the cloud inside of InfraWorks. The usual method that the civil engineer goes through to do that inside of Civil 3D is basically going through these 6 steps, more or less. It can be a little bit more, but these are the basic ones. So first, we have to identify the culvert location. We have a certain road, we have a certain low point, and a stream crossing. We need to analyze where do we have to place our culvert, the pipe that will take the flow from one side to the other. Here we're using HydraFlow extensions. These are additional extensions inside of Civil 3D, which can be used to design the culvert, etc., etc. And from HydraFlow, we can determine with Civil 3D the elevations of the culvert, the pipe, and size them, and then create the pipe and the end walls. So it's a tedious process to analyze the terrain, know what type of culvert to use, what is the size of the culvert, so on and so forth. So as you can see, pretty much detailed. Once you move into InfraWorks, it's much, much easier. Inside of InfraWorks, because you have this 200 square kilometer model, you can analyze a big amount of terrain. And with a single click, also utilizing the drainage module, you can create watersheds, create culverts, check the watershed flow, and create the culvert to a certain size. Let me move into the video directly. So this is inside of InfraWorks. I want to create the watersheds. I go into the drainage module, I activated it, and then I ask the software to create the watershed that is affecting that road that I am designing or I have in mind. Now I have certain settings as a hydrology expert. I change certain settings, and then it will analyze the whole terrain automatically within a few seconds using the cloud. And then on the fly, it will show you visually where are, let me pause a second, where are the watersheds. So it will delineate, it will like draw for you where are the watersheds, right? And it will show the stream, so the water is flowing those sides here, and it's crossing the road over there. Not only it will show you the watershed, the stream, but it will also show you where is the point where you have to put the culvert, the pipe, that will take the flow from one location to the other within a few seconds. So we move into that. We zoom into that point where the stream is crossing. And as you can see, we're going to add culverts on the fly. So with few clicks as well, the software on its own will generate the culvert based on the design standard that you have in mind and the flow that this watershed is creating into the stream. So here we're selecting the method through which we're calculating the flow, whether it's regression or rational method, or you can have your own method if you have one specific for Turkey. You have some other parameters like the Manning number and others. You can input them if you have them. And then on its own, the software has created the culvert for me, as you can see there. And definitely, it gives me the option of changing the shape of the culvert and gives me all of the required analytics. So I have the upstream flow, downstream flow, upstream velocity, downstream velocity, etc., etc. So it's doing all that within less than 1.5 minutes versus the 20+ minutes inside of Civil 3D. And then the story continues. We get that from InfraWorks, we open it in Civil 3D, and thereon we can create the cross sections and the sheets for the construction documentation. So this is why both tools work together. The power of InfraWorks, again, is utilizing the cloud, the computation that is done in the cloud, and pushing that back into your machine to show it visually in 3D, whereas Civil 3D is perfect for detailed and documentation. So again, a summary, detailed and tedious process versus a 4-step process. And by the way, the accuracy we're talking about, it's the same, because InfraWorks 360 is utilizing the calculations of Civil 3D in the background. So we're not talking about, well, it's conceptual design, then it's not accurate. It is accurate, it's as per the design standard, as per the terrain and the waterfall. And finally, for the detailed design, this is where we utilize Civil 3D, where it's necessary definitely for getting, for example, the survey data, creating the existing terrain, showing the profiles, the cross-sections, the labeling, and the production of the plans. So definitely you're aware about that, so I'm not going to spend a lot of time. These are the 5 points that I wanted to cover and show you the benefits of using each. Okay, I just got 5 minutes to go. As expected, I've prepared a lot of extra material. I know people are not aware about InfraWorks. There are many ways of pushing data from InfraWorks to Civil 3D. And okay. Is this a sign that I should stop? Okay. So there are many file formats which can be used to push data from InfraWorks to Civil 3D. We have the SQLite, we have the DWG, we have the IMX and shapefiles. In my presentation, which you will get later after the event, you will be able to see what objects or what things can be used and how best to move data from one software to the other. Okay, this is just an example of InfraWorks. So I'm laying, there is a certain road, a highway, for example, a 2-lane highway, and I'm opening it in Civil 3D. You will see that it will open instantaneously. I just have to select the area of interest, open the InfraWorks model. I'll be able to pick what data I want to import. Here we've got the terrain, for example. If we have watersheds, we have the alignment of the road. And let's suppose that the civil engineer, let me just move here, wants to update or change the corridor of the road there, right? We're changing the alignment, we're regenerating the corridor. See what happens in Civil 3D, and with a single click inside of InfraWorks, I'm going to the data source, right-click, refresh, and how that directly updates in 3D live. So the way things are being done now in infrastructure has changed with InfraWorks. You're able to do things in Civil 3D, push them to InfraWorks, and show it to your customers in a very visually compelling way. The others, since we're running out of time, so these are the slides which I've prepared on how to move data back and forth. What are the data, for example, using SQLite or IMX file, and moving data, for example, from InfraWorks to AutoCAD, Civil 3D the same way. So this will be all shared with you later after the event. This is my email address. Where is it? In case you want to send me specific questions about the two, please feel free to ask your questions now. Yes, please. Yes, Project Boulder for flood simulation. It was actually integrated in the latest release of InfraWorks. The only thing is that you have to have another plugin called Hydronia River 2D. Yeah, it's coming with InfraWorks directly. Yes, so if I open InfraWorks, so these are the, by the way, this is just an example. So this piece of land, I showed this model. I developed it myself inside of InfraWorks, and here where you can create proposals into, for example, different alternatives. Let's suppose traffic one. Here at the very top, you have the basic functionality, the road, the bridge, and the drainage. So it's now available in the drainage module. So these roads can be alignments from Civil 3D, by the way. If I go into the drainage module, I go to the analysis tab. This one first. Rainfall content. Create watershed. Maybe I have to, just a second. It's already there, but you have to have the, I don't have the plugin. Because that plugin from Hydronia is not by Autodesk. So there's another company which created the flood simulation. Once you download that plugin from their website, you install it on your machine, you will have the icon inside of InfraWorks 360. But you have a Project Boulder, right? Project Boulder is ended, was cancelled. Now the only workflow is that you have to download a plugin called Hydronia. I can send you the details from them. Yes, from Hydronia website, not from Autodesk. Because they're a specialized company in hydrology, they've developed this plugin which works with InfraWorks. but I don't have the plugin, that's why it's not showing here. Yeah. Yes, please. It's okay. Okay. Most of the functionality is local from your machine, but the ones that require calculations, like for example the watershed analysis, it requires cloud credits, yes. So depending on the area that you're analyzing, it will consume cloud credits from your account. Yes. Watersheds, we have also the traffic and simulation analysis. Yeah. And the corridor and profile optimization. Yeah. Yes, please. Yes, model builder. Mm. Yes, you can. Istanbul, I did not create. I created one for Dubai, but if you like, I can do it for you and send it as a video. Or else, I recommend it's better to go on the Autodesk website, download the free trial version of InfraWorks, and try it yourself. It's free. So you will have the software InfraWorks 360 with all of the capabilities. Yeah, exactly. Hmm. The ones I showed you, all from InfraWorks, even for Istanbul. Any area in Istanbul you select it, it will create it for you. From within InfraWorks, there is an option, capability called Model Builder. So there is a certain window. You click on Model Builder, it pops up a window. It tells you what is the area of interest. You select the area of interest, create model, it creates the model, open it, and shows you the way I showed you that 3D model. So you don't need any other software. But if you want the terrain only, okay. Hmm. You can open that in Civil 3D. Yes, yes. Yeah. You can open Civil 3D itself, and in Civil 3D, if you have the latest two releases, 2016, 2017, you have an icon, open an InfraWorks model, and then it tells you what is the area of interest, where it directly open the InfraWorks model inside of Civil. And this is the cool thing, they really integrate with one another. They're working perfectly together. Any other questions? Yes? Sorry, I cannot hear you. Again, please. Yes, definitely. Actually, you can read any type of data, whether 2D or 3D. So if I move here, for instance, this is what we call the data sources. Whether you have 2D, Bentley, or you have 3D, if you have GIS, Esri, you have Revit files, you have AutoCAD 2D layouts, all of that you can bring it into InfraWorks and show it in your model. That's the cool thing about InfraWorks. Think of it like Navisworks, the platform where you throw things and it will aggregate the model the same way InfraWorks does it. Yeah. Sorry, it's not projecting. Currently, we export into DWG, IMX, and the 3D models like OBJ, FBX, and Collada. If Bentley can read IMX, then it will be okay. Or else, the thing that you can do, use Civil 3D, and then from Civil 3D, export it into DGN, for example. Yeah. Sorry? For rail, we have sketching capabilities of rail. So we have styles and we have the alignments. You can sketch them in 3D, yeah. But not the design parameters. Yes, you can. There is a style editor. You create the, for example, the cross section of the, or the assembly of the rail, and then you can sketch it inside of InfraWorks. Quantification is in Civil 3D, to be honest, for rail. Here it's on. Sorry? We have quantification, but for the roads. So if you're designing any road on the fly, if I click here and I sketch the road, on the right-hand side, it will give me directly the cut and fill. It will give me the cross sections. It will show me the super elevation and everything. For roads, it's a complete solution. But for rail, no. We just sketch the rail. We use the rail layout module inside of Civil 3D to do all of the design, taking into account, for example, the cant and the switches, etc., and the quantification. So it's done in Civil 3D. Yes, please. Yeah. We need like 15 minutes, to be honest, because what will happen, I will select the area, but then we have to wait 10 minutes to create it in the cloud and 5 minutes to download. Okay. Yes. Perfect. Thank you. Any other questions? Yes, definitely. Definitely. Yes, optimization, yes, and design, yes. Whatever you create for the roads specifically, if I go here, the design standards like AASHTO, the different design AASHTO standards are already built in. So whenever you're doing any design, it's taking into account the design standard, the speed, the design speed, the curvature, horizontal, vertical, etc. And for the optimization, we have two types of optimization. For roads specifically, we have the profile and the corridor optimization. So if, for example, I know that I want to sketch a road from this point to this point, right? And it's a straight one. So the software knows I am specifying the alignment, right? I can ask it to optimize the profile. It will optimize the vertical profile for me to minimize the cut and fill and minimize the cost. But this one also requires cloud credits because it's done in the cloud and then pushed into your machine. And the other thing is the corridor optimization. Let's suppose I have a point here. We don't have those roads. And I tell the software, please connect this building here to that building over there. Show me the best road with the minimal cost, taking into account certain parameters. Think of it like a generative design, the one that our vice president talked about today. You specify areas to avoid, things to create like a bridge if you go above 20 meters. It's very, very, actually very intelligent, yeah. And there are videos on it. If you send me an email, so you've got my email address already, right? Just send me an email and I'll be very happy to send you those specific capabilities. Okay, thank you very much. Thank you for attending.